Okay. Recording is on, in case anyone cares.
Thank you for doing it.
Funny how everything got quiet as soon as you said that, Joe.
Yeah.
Big Brother's watching you.
I don't know what happened to the weather. I went out to Dallas Road to get a southerly view and everything clouded up.
Oh, I know exactly what happened. I borrowed the club's solar telescope.
Well, it's both Emer's fault. That's clear then.
Yeah, so there we are.
Actually, at lunch, I did get to use it. It works.
Solar scope equals clouds. Yeah.
I did have a quick look at the sun today between breaks, but the sunspot on it was so small I couldn't see it with binoculars.
Mm.
What kind of scope is the solar scope? Is it Coronado or?
The club has two. John is borrowing one with a double echelon. I think it's Coronado, isn't it?
The one I am using is a Lunt.
Yeah, Lund.
Hunt. Okay, and the one I'm borrowing is a single echelon, 40 millimeter Coronado.
That's the original scope the club owned.
And a really nice mount. I'm wondering, is it possible to get
That's
a
the
good
one with the
mount like
eyepieces
that?
too, isn't it?
What?
Yours, the Lunt, I think. I think the Lunt has eyepieces with it.
It has one eyepiece.
Yeah,
Oh.
the Solar Max has a collection of eyepieces, and they like to say that they're specially designed for solar scopes. They're blackened on the inside.
Yeah.
Is that the only difference?
I don't know, I'm not sure, but that's what they say. They make sure there's no reflecting surfaces on the inside.
And is there any reason for me not to use my own eyepieces?
Certainly can. There's no reason not to. I think the biggest help in solar observing is to have something you can put over your head,
Yeah.
like a black cloth to put over your head.
Well, the club also provides that.
Oh, did they?
But the worst reflection comes from below.
Yeah.
Like it seems to come off the ground and then reflect off your eye. If you hold your hand underneath your eye while you're observing, you don't really need to shade above. All the wreckage is from below, I found.
No way. How about that?
Okay.
Maybe
It's really weird when you bring it up, all of a sudden, all the weird reflections go away. It's like it's off your cheek or something like that.
maybe you need a black tube or something to poke your head through.
Speaking of reflections off the ground, I should tell you the story again about observing out at Blackfoot staging area in the winter with snow on the ground, and you have bright aurora in the sky or just a relatively bright sky. You need a dark cloth over top of your head to see anything. The problem with that is when you're breathing under a dark cloth, you tend to fog your eyepieces. So some guys have taken to breathing through a snorkel when they're under the dark cloth.
It's brilliant.
Only on the prairies.
Yeah. Only when it's minus 12 or 15.
Yeah.
I'd love to take a picture of them all and put it in some newspaper someplace.
Yeah.
Okay, Dorothy was here and has left. I don't know because she's one of our presenters tonight, so maybe she's having computer trouble, but we'll just give her a moment or two more. maybe while we're waiting for her to come back, I'll just remind people that we do have the calendars for sale. If you haven't gotten one already, those are the $15. I have some and Lauri Roche has some. We are looking for nominations for both council positions and center awards. So just a reminder that we're planning to have an annual general meeting. Well, under our bylaws, we have to have it pretty much by the end of February. So we're looking at one of the dates in February. And I believe we'd mentioned that the Observer's Handbook were late in being shipped. And I'm hoping that most people have gotten theirs or they'll be arriving shortly. I see
mine.
Yeah, thumbs up.
Mine.
So of course, we're probably some of the last people to get them because it seems to take forever for mail to get here from Ontario. But anyways, if you haven't gone, it should be soon. Dorothy, are you having trouble connecting? We haven't seen you yet.
I'm okay.
We can hear you, but can't see you.
Whoops. I've been trying to figure out how you can see me, and that's why I've been coming and going. I have my camera on. I mean, you don't have to see me. I haven't changed since the last time you saw me, but it's...
Yeah. Let's see, what's it saying here for you? Yeah, it's just saying, basically it's saying you don't have a camera connected at the moment or it's turned off.
Well, I just checked my settings. I'll do that again.
On the bottom bar, do you have a choice to start video near the bottom left corner?
Oh, yeah.
So what happens if you click start video?
Wait a minute. Start video. Okay.
There you
Oh,
Amazing.
Very good.
Nice to see you.
Welcome everybody. So it's this is our December 14th shutter at the date there, Astro Cafe. Welcome everyone. And we have a few people who want to present this evening. I'll just re-mention again that we still do have calendars for sale. We have an AGM coming up in a couple of months. So I sent out another email calling for nominations today. And the Observer's Handbooks appear to be arriving. If you haven't gotten yours already, it should be there soon. As you're probably aware, we have Jupiter and Saturn getting closer and closer together. And Randy has been measuring that over the last little while. And so he would like to give us an update on what he's discovered using his sextant.
Very good. And
picture.
Share screen. Is it gonna work?
Yeah, we can see PowerPoint. Yeah, there we are.
Okay.
That's your house or nearby.
So
see you.
Here I am. There's Jupiter and Saturn to the southwest of my house. And I've got this contraption here, kind of dark in this picture, my sextant. And I just want to talk a bit about using it. But first of all, let's take a look what's happening out there. So 1, 2, third rock from the sun. And by the way, this is inthesky.org. It's a very nice little app. And you can see Mars is beautiful there in the evening sky. There's Venus in the morning. But just before the sun gets in the way, we have Jupiter, and I drew this yellow line on, and very close along that line of sight is Saturn, and that was December 7th. There it is a week later. The biggest motion, of course, is the Earth is zipping around once a year. And what is it? It's 10 years for Jupiter and 25 for Saturn, something like that. Anyway, when you go to the 21st, they're all in a line. So I find this a very good way of seeing what we're actually getting to watch. And just because this year, it happens every 20 years, but this year, it's not just their great ascension that will be, they cross every 20 years, but their declinations are going to be a 1/10 of a degree apart. So 1/5 of the moon. Okay, so this is what we can expect. The sad thing is that it's very close after sunset is the only time that we'll see this conjunction, because the planets are going to set right after they it's dark enough to see them. If we could see them during the day, that would be great, but we can't. But every day they're getting closer and closer. And so here I am. I'm not actually measuring Jupiter and Saturn. This is during the daytime. And when I said to Chris I was going to talk about this, he said, well, how about you talk about how a sextant works? It's a lovely machine proposed by Newton. Newton was the one who had the idea of how, in principle, one could make accurate measurements using 2 mirrors. And this was a big advance over the Longstaff.
Oh, here's Randy with the sextant.
So here are the parts. So the important thing is we have what's called the horizon mirror and the index mirror. And the index mirror is on an axis, and we can move it along this arc. And it's got a little gear so that with this micrometer, you can move it very accurately. You also have these shades when you're looking at the sun and things. It's kind of freaky when you look at the sun. You got to make sure that you've got the shades in place before you do that. And this is just a little 2x telescope, which does help, but you can also run a sextant without any telescope. So what you're doing is the horizon mirror, there's different sorts, but the most common one, it's half mirrored. So you've got the glass, and then you've got half of it covered with the reflective surface. And when you're looking at the sun and matching it to the horizon, then this is a very handy arrangement. But when you're looking at 2 dim objects like the planets, or even, my normal measurement that I do every time I see the moon is I measure the diameter of the moon by matching the top and bottom of the moon. And then all I do is I look at the reflection in the glass itself. So I don't use the mirrored part at all. I just use that very faint reflection in the glass. And then that bounces off this mirror, which pivots. And when you match up the items, then you can see what the angle is between them. So Bill, I borrowed your picture that you posted because I can't take a picture through the sextant as I'm doing it, but I wanted to simulate it. So this was Bill's picture from Saturday night of Jupiter and Saturn. And so as you move the mirror, this would be the mirror set at 0. And then as you move it along, then you would see Jupiter and Saturn get closer and closer. And then you say, that's it. And then you go a bit too far and you say, oh, no, got to go back. And then, because you can't actually see Saturn under the glare of Jupiter, then you pivot around a bit and you say, yeah, that looks about right. And then you put it back. And you do this, iteratively till you get it till it looks just right. And then you look at the scale. So you could just do it looking at this arrow and seeing where you are on here, but that's not very accurate. So you also have this Vernier scale. So this would be, it's between 0 and 1 degree. These are degrees here. And that says 47 minutes and 30 seconds here. Those are lined up there. You could just read it in there. So you're halfway between 47 and 48. Okay, so that's how you measure with this. And so far I have taken 7 measurements, and if they were actually going to meet, if they were going to eclipse each other, then it says, and this is Pacific time, it would say that around midnight of the 21st, of the 22nd would be the closest approach, but it doesn't actually make it all the way down to 0. So this is actually pretty good. We expect it to be on the 21st at noon Pacific time. Anyway, I plot on this what clever people with better measuring devices have figured out. And, you know, my points are going over what the real astrometers are figuring out. So that's pretty good. So unfortunately, this is really what's going to happen. I know is we're going to get closer and closer. Then we'll get clouded out. But you know, we do what we can. That's my talk.
Yeah, very good. Any questions for Randy?
Thank you.
Chris, I've got a comment about the weather.
Sure, please make it.
Could I share the screen?
Absolutely, you should be able to.
Okay. Just a sec. Trying to find, let's see here. I'm sorry, I can't find my PowerPoint thing. I'll just try and click on the PowerPoint thing here and see if that works. Can you see anything?
Very good.
Yes.
Yep.
Okay, let's play from the start. So I'm recommending here not quite so great conjunction that we focus on. So this is the arrangement of Jupiter and Saturn on the 20th of December. And you can see the moons are quite close here. I did not realize that the moon Phoebe is associated with Saturn. It's really a long ways out. It's 4 times farther than any other moon in Saturn. It was interesting to me. But if we, that's on the 20th. This is at 5:30 p.m. on the 21st. So I'll just go back. You can see that it's a little bit closer on the 21st and the 20th. But you can make measurements using what I did here. This is with Sky Safari. You just have one item and you double tap on the other and it'll calculate the distance between the two. And I did that for both the 20th and the 21st. And then I put everything into kind of a form here. So basically the close encounter between Jupiter and Saturn takes place at 5:22 a.m. Pacific Standard Time. And both planets are well below the horizon at that time. That's on the 21st. And on the 20th, Jupiter at 5:30 p.m., Jupiter is about 5.5 degrees above the horizon. And the angular separation between Jupiter and Saturn is about 7 3/4 arc minutes. And on the same time on the 21st, roughly again, it's at 5:30 p.m. Jupiter is just above 9 degrees above the horizon, still kind of usable. It's just nearly 6.5 arc minutes. So there's the difference between the two on the 2 nights is 2 diameters of Jupiter. So it's slightly closer on the 21st than the 20th. Now, my concern is this is the 180-hour forecast for the Monday afternoon or evening. And this feature here is an intense low pressure system, and Vancouver Island is here. And associated with this is the green area is a predicted area of precipitation. And so it looks like we would be under the cloud shield on that day. So this is 180 hours out during a very dynamic winter season. It's easy that these things could be seriously in error at that time. But if we go back 24 hours earlier, that system is further offshore Vancouver Island here. And you can see some green area here. This is because the system traversed the coast earlier that day, and it's actually over here. So we have a ridge of high pressure, which is kind of a good news, sinking air, possibly clear skies. So I'm suggesting it might be wiser to have a crack of it on, have a look at it on Sunday rather than Saturday, and than Monday. So if there is a problem on Monday, you might have salvaged something. So so that's basically my advice at this time. So I'll stop the share there. So there you go.
Yeah. Yeah, thanks.
Interesting. Yeah. Well, and thanks for the for both those presentations. So we're try and see if you can catch a glimpse of that. We were thinking of maybe starting a little earlier next Monday if it were clear, but I guess at the moment it's looking like it probably won't be. So maybe if we're going to have Astro Cafe at a regular time, we'll hope to have some photos from Sunday. Maybe.
I have an astrophotography question. I'm sure when they both can be in my eyepiece by visual, it will look spectacular, but they're so different in intensity. What will it look like with the camera?
So Randy, I shot it with I think about 480 millimeters, maybe a week or so ago. You can actually, if you zoom in, you actually see Jupiter with the satellites. I saw that. And Saturn, unfortunately, being a little bit dimmer and a little bit smaller, kind of just looked like a football. That's what it looked like in a short telephoto.
I would suggest bracketing it because it's a couple stops different in my experience. So
they are dim.
do
Saturn is
a
substantially
few,
dimmer.
you know, just a couple stops apart and then composite them, because otherwise you're just going to have one thing blown out and the other one super dim, and it's going to look, you know.
Yeah, even visually, the last few times I've seen it, you certainly see Jupiter first.
Oh, yeah.
And you kind of strain a little bit until it gets darker, and then you notice Saturn.
Well, you can't. I find about 4:30 Jupiter seems to be visible, but once you find Jupiter, you can usually see Saturn, but you never see Saturn first.
It's quite pretty in binoculars.
Yeah.
When I was out at Dallas Road the other day, I took the binoculars with me, and they fit quite nicely even now inside of the field of view.
If you're photographing them and trying to get a better range, if you have a high dynamic range setting on your camera, that might help as well.
Yeah. I think compositing probably makes a little bit more sense. They're quite different.
Yeah. Video works better for planets, and so you can just do, you know, a minute of video with, you know, exposure set for Jupiter and then switch it to Saturn and do another minute or two. And the seeing is going to be terrible anyways this time of year. Planets are awful. In the middle of August, when you're in the middle of a high pressure, the seeing can be amazing, but I've tried a few times this fall and it's just disastrous.
Yeah, that combined with how low an altitude they're at,
Yeah.
I think I would favor visual observing personally.
Yeah.
I mean, unless you just want to record the moment. But.
Yeah.
Yeah, basically that's all I'm going to do. I don't expect it to be, you know, that amazing. Just a reminder of where it was, and hopefully near the landscape.
You're not getting any Cassini gaps in this.
No.
No,
Not expecting it.
Told me might be a good place to try.
Yeah, Dallas Road was
Little extra
okay.
separation from the horizon.
Yeah, you want, it's very low. So you
Mhm.
definitely want to go to a
yeah, we're not looking at
a
anything
place
too
that's
high
shown.
up. Yeah.
Yeah.
Some good hints. Anyways, well, good luck for those of us who want to go out and see it, and hopefully we'll get to see something and share what we found out on Monday if it's worked out. Next, we have Dorothy, who is going to talk about our Venusian neighbors. So if you're ready, Dorothy.
Okay, so I go to share screen,
Correct.
share.
And it should give you some choices, yeah. And
Well, how do I get my screen? Whoops.
it
You
gives
are-
you some choices of what you share. So you want the presentation. So maybe you might need to stop share.
I should see my.
Yeah, we're
I've
seeing your
got-
Zoom page at the moment.
Wait a minute. What do I have here? You are sharing, it says.
Yeah, but we're seeing Zoom at the moment. We're seeing your browser.
Scheduling made easy. You're not seeing
Yeah.
my browser.
Yeah, so we're seeing that one there, but not your presentation.
So how?
Minimize the screen.
Yeah, can you get rid of that? And is there something else there?
Try.
Yes.
Oops, I don't want.
No, minimize your screen with the little line on the right-hand side of your.
Yeah, so get rid of that. And do you have a PowerPoint, is it?
Yeah, it's you should. I've done this before. I thought I was going to work this time. Okay, you
Maybe
see
minimize
me.
that as well, because you don't.
No, go to your PowerPoint icon, the orange one.
Do you see?
Keep going to PowerPoint. That one, yeah. Click on that.
Okay, so I need to get. There we go. Okay, I have
there it
a
is.
join Zoom thing hiding it from me.
Okay, so yeah, just open that then.
Okay, we're in business, I think.
Yeah.
Try to be.
Yeah, and then you just need to
Okay.
turn on the show. Yeah, that's right.
Okay. Well, how can I get rid of this? I want to get rid of that. Okay. So our Venusian neighbors. This, of course, is that they're there is still hypothetical, but it's a very strong hypothesis. And what I'd like to hope to leave you feeling is that this could be the year of Venus as well as the year of the pandemic. So the first thing we have to consider is how might we detect life next door? And first of all, we have to know how planets and life originate and evolve from one example, so we know what life features might be detected. And then identify some potential unambiguous biosignature molecules that we could detect from afar. So we have to start at home. And the second, so that's my intro. And then what is the evidence for Venus? That's for life on Venus. And that's where this year has been really quite spectacular. It's 3 major papers. There have been indirect signs for some time. And this year it's a biosignature gas, which has been identified, has been shown to be present, and adding to the evidence. And then finally, I'll give you a plausible Venusian life cycle, which is really a testable hypothesis. And it's really quite interesting, but we have to start from the beginning. And gas cloud, where nebulae, where stars and planets get started. And these contain all the raw ingredients for planets and life, minerals, of course, all the elements of the periodic table, except depending on where you are in the cloud, there may or may not be the super heavy, highly radioactive elements. And that's something to consider in planet formation, of course. minerals that are interstellar dust, which serve as points for allowing molecules to form. Molecules, lots and lots of them, hydrocarbons, many of them, organic molecules keep turning up. These include familiar ones, glucose, excuse me, amino acids, nucleic acids, really an amazing array. I could go on with that, but all this starts where condensation of these gas and dust forms stars, and we get a protostar, which gives some sun-like star, and a planet or planets, and some of them are rocky planets, such as there are 4 planets in our inner 4 planets in our solar system. So if we look at our solar system's rocky planets, this from a general, pretty accurate, although the timescales aren't quite right, adaptation from Scientific American article last year. Of course, we have the planets forming from small planetoids congregating, converging onto becoming a small planet. The red on these lines is volcanic or tectonic activity, and a little bit on Mercury, but died out. The rest of the planets, or Venus and Earth, continue today, and Mars petered off apparently at some time after several billions of years. Purple liquid water, essentially, well, none really on Mercury. Venus early and petering off, and that pretty much hold off. This is surface water, of course. On Earth building up, and we have it till today. So green conditions for life actually started on Venus or before Earth, and perhaps briefly on Mars, but then things changed. So what the question is, assuming that life, given the similarity of these planets, and we'll come to that in a moment, that life may have continued as conditions changed on the surface. So this, first of all, this paper from 2016 summarizes a lot of the earlier work, and the main conclusions or that are pertinent to this story is that surface water and habitable conditions existed on Venus for at least 3 billion years, and maybe until much more recently, like even until about 700 billion years ago. And the other important feature for early Venus is the storm clouds that shielded the surface from strong sun cloud and made the planet habitable. And there's this climate modeling is available online. It's easy to, if you're interested in following this up. Venus now is, the surface is an infernal, very, very hot. But the atmosphere, it's mostly CO2 and water droplets with a lot of sulfuric acid, very acidic. But these dark patches in clouds are concentrated sulfuric acid and other unknown light-absorbing particles. And these have been watched for decades. In fact, these dark patches are things that Arthur C. Clarke and colleagues noticed and proposed that there might be a life in the clouds, cells in the clouds of Venus. What was that, 30 or more years ago? The upper atmosphere UV flux is about the same as it was on the surface of Earth in the Archean period, a time when there was photosynthetic life. and it's quite attenuated. So the difference now between the surface and the atmosphere of Venus is worlds of different, basically completely different habitats. And it's worthwhile noting that there are bacteria on Earth that are not completely characterized, but they're known to have light absorbing properties similar to these unidentified particles on Venus that make up the dark patches. And these have been, of course, and are being studied further. So just taking this summary table of the twins from NASA, surface is kind of out of the question for life, at least we think, for life is continuing. But if we look at that 50 kilometers up and compare to the surface of Earth, there are lots of regions on Earth where their life is living happily at higher than 75. The maximum is 95 degrees C that I know of. And it's so hot that it's been hard to characterize these microorganisms because they die at cooler temperatures, and the temperature is so hot that all the equipment, that even the thermophiles that have been studied, the plasticware and all the equipment kind of melt at 95 degrees. But if we look, my screen, sorry. Back up. If we go down this list there, so we can see that comparing solar power, radiation shielding, third down, pressure, similar in the atmosphere at 50K kilometers and on Earth, density comparable, gravity comparable, not that different. If we had the proper suit on to allow us to breathe, we could be reasonably happy, and certainly many Earthlings could be. So the question now is then, could these thermoacidophilic extremophiles, as they're called, inhabit this temperate acidic upper layer of Venus's atmosphere? Just to give an idea of the microbial communities on Earth clouds. So this isn't so far-fetched. This graph is from a very detailed study, and I won't try to explain it all. But it basically is a genetic study of a large body of. I'm sorry, and there we go. Large body of microorganisms that have been collected from the atmosphere of Earth. This on the left, the slashed lines are eukaryotes, cells with nuclei, and the unslashed are prokaryotes. And the pink is one genetic technique looking at the genes, the metagenomic, and the MT is transcriptomic. It's written up at the top, which is looking at how the genes are expressed, read out. So it's even more detailed. And you see there are a lot of data and a lot of going on up there. And the right-hand part of this lists the classes, and there are many genera in this, and a lot of them haven't been characterized. And the main point that we want to take from this is that there's a very rich assortment of microorganisms that are in Earth clouds. Now, they don't reside there all the time. The reservoir is on Earth, but this schema just shows how this works. Again, I think just pictorially, you can get the idea of organisms, the green arrows showing biological processes, the red arrows abiotic processes, dissolved organic carbon being taken up, so on. And secondary aerosols be left out. That's part of what gives us kind of crummy skies if there are a lot of clouds around, a lot of microorganisms in them. So this is aerial life, not going to be the same as on Venus, but it shows that microorganisms can exist for some time and actually in the atmosphere. And of course, for us, they're transported widely and is an important part of the geochemical and ecological aspects of Earth, planet and life interactions. So let's take a look at infant Earth now, going back to the start. So we formed with soon with a core and silicate mantle, and then, as you know, we had a big crash and the moon resulted. The Earth's been turning on its axis, giving us a daily rhythm of light and dark and an annual rhythm because of the tilt of the axis, and which is, of course, different, would be not existent for a planet that's not tilted. We've had a magnetic field from early on. This ancient field that was actually a modeling of a later time, about I think 1.5 to 2 billion years after the start that was done. But the point is that even a weak or partial magnetic field can provide some protection from radiation. The first crust that formed back, when you think back to my first figure of a solar system forming, was eroded away by continuing bombardment of crust, and it contained, and this is fairly recent geochemical data, a lot of or more heavy radioactive elements, so that the crust we have today does not have this. And this again could be important if, depending on the first crust that forms on a planet, if it contains a lot of active material, it'll be hotter and it'll produce a hotter surface along with everything else, implication for whether and when life might form. Life appeared quite early on Earth. I'll go on with this in a moment, excuse me. But one thing that happened, and this is an ugly figure, but it's very interesting. This shows mineral evolution starting at the beginning. Sorry, but the scale is reversed from the one below, but Earth started with about 12 minerals. And for the first 500 million years, they, excuse me, they increased gradually, and then they started to accelerate, and we see a large and later acceleration and introduction of new minerals, and this is underestimate of the number that are known now, and these are primarily biologically produced. As Robert Hazen, who's actually the senior author on this work, commented, he's had a mineral name for him from one found in Mono Lake in California, and it's called hazenite. And he says, I've had a mineral name for me. It's microbial poop. So what happened next? Young early to produce life, energy from proton gradients, which have been shown to form in tubes, volcanic tubes and hot vents and around the base of volcanoes. This is separating charges basically, and combining with phospholipid bilayers that something is known, but not too much about how that could happen, which would put these proton gradient, which is actually provides a charged chain that can say exchange hydrogen for sodium across the lipid bilayer and lead to chemosynthesis and life and bacteria as we know it. There's a lot more to be said about that. It's hard to leave it out, but there's not time for it. But soon after that, relatively speaking, another group split off, or the bacteria split. There are bacteria and then an offshoot, you might say, the archaea, and a bit later, eukaryotes, cells with nuclei, which arose from archaea. So we're more closely related to archaea than we are to bacteria. Very early on, genetic studies have shown the first circadian clock genes appeared. That doesn't mean that all of these organisms they're single-celled organisms, had sophisticated clocks, but they had genes that involved a cycle of synthesis and degradation that is the beginning of forming a clock. And actually circadian clocks evolved in a number of animals. And this is important point to notice on Earth, because it turns out that for organisms such as ourselves, multicellular organisms, animals, that the metabolic cost of keeping a circadian clock going is quite large. Something like one experiment has come up with at least 17% of our metabolic energy is expended on keeping circadian clocks going. And that is presumably important because of the importance of being ready for the change between hot and cold as the Earth turns, and of course changing with the seasons. Multicellularity happened a number of times, quite a bit later, you can see, and metazoa, animals after this. But I'm not going to go on there because we're not interested in what really happened in Earth later. We're interested in how life can get started and how it interacts with the planet. So I stop at this point in following what's happening on Earth, because this is red line marks about the time, as we saw previously on Venus, where Venus's atmosphere changed. Venus supposedly became uninhabitable. And just to remind you of where we are now, with a huge tree of Earthlings, that all of, can I move this without? All of these are bacteria, archaea, and eukaryotes. That's us here. We're off here on this sun line. Okay, so this is young Earth, what happened up till now. What about young Venus? What happened here? Well, we know that retrograde rotation, for whatever reason, a long, slow rotation, but no axis tilt. So it would seem that circadian genes, as I've just talked about, would not be advantageous, or considering their cost. Habitable surface, as we've seen till quite recent. So why not the proton gradients, phospholipid bilayers. It started with the same basic chemistry that Earth had, leading to life. We don't know what to call the organisms, but photosynthesis, there's certainly plenty of sunlight. Anoxygenic, not making oxygen, maybe making oxygen. And what happened then? Well, the question is, what happened when this? Did life go on? And is it possible, given the livable conditions in the atmosphere, that Venusians moved into the atmosphere? So are our Venusian neighbors floating in the clouds? So this year, 3 papers have provided nice, really strong support, I would say, for this hypothesis, which it remains, of course. First of all was one showing that phosphine as a biosignature gas could exist. The one that made the headlines in early September is the discovery and identification of phosphine gas in the cloud decks of Venus. And that's actually what started me on this, because it and took me back and on to discovering this one, the Venusian lower atmosphere as a depot for desiccated microbial life and a proposed life cycle for persistence of the Venusian aerial biosphere. So I'm going to just go schematically through these in this order. Phosphine as in the atmosphere. This and Randy, I really need to thank you. Sorry, I don't mean Randy. Reg. Reg, thank you for, in the 9th of November, mentioning this talk, because I probably wouldn't have seen it. It is online, and you could, and I would highly recommend it if you're all interested in this, because the Clara Sousa Silva is a fantastic speaker, really good, probably the best speaker, speaks impeccably, and is very dynamic and a very interesting person. And I'd already seen the paper, but I was delighted to actually sort of meet her, so to speak, in person. And I'll just, this work started as her graduate work. She and colleagues have collected a huge list of potential molecules that one can detect on Earth's atmosphere or from afar that could possibly be signs of life, but ones that life could emit. But of course, the question is, are there other sources for making them? And additionally, once you've found ones that only life can make, or are there the spectra for them known? And in fact, at the moment, with 16,367 molecules, maybe more by now, there are fewer than 4 of them have spectra that can be reliably identified, good quality. And one of those is, of course, phosphine. In fact, that was the first one. This is one graph from the paper. There are many others, but the black line shows phosphine along with other elements picked up in the spectra. And although with some gases, the spectra is quite similar, but still distinctively different, and adequate with careful analysis of the spectra from radio telescopes to pick out. So going to the September paper, which I've noted up in the upper right. I just last week discovered that it's kind of an update. It's not that there are new data, but reanalysis of more data and data actually going back 40 years or so that have been collected by earlier first probes sent to Venus have provided more data. So it was spotted first with the James Clerk Maxwell telescope in Hawaii, and then confirmed with ALMA in Chile. It's faint, but it's the right wavelength, mid altitudes, 50 to 60 kilometers, mid latitudes, that is around the equator, sorry. And the amounts, 20 molecules about in every billion, sounds like not very much, but could not come from natural non-biological processes on Venus. They did extensive analysis and computation to show that this is the case. And the non-biological sources, volcanoes, lightning, so on, could make at most 1/10,000th of the amount of phosphine that the telescope saw. Now it's a very small amount, and was pointed out, and the authors pointed out initially, this is a small signal, but it's clearly there. It's been seen by both these telescopes, data collected over several years. The ALMA data were a couple of years later than the JCMT data collection. And so it's hopeful looking that this might truly be real. And the last point, not the last, but another point that's interesting to note is that terrestrial organisms, to make the equivalent amount of phosphine has apparently exists in Venus clouds, would have to work at only about 10% of their maximum productivity. So it's not as though the Venusian microbes, if that's who's producing this phosphine, are laboring hard. So how do you live in the clouds of Venus? And this comes to this last paper, and this is very interesting. It's easier to look through than to really illustrate, but here we have a diagram showing the Venusian atmosphere from surface to about 100 kilometers up. And the middle and lower cloud layer is permanent and continuous around the equator. And a temperate zone, as we've seen, temperatures and conditions, apart from the fact that the sulfuric acid, but the conditions are basically suitable for life as we know it from Earth, as we've seen. So this kind of complicated or strange picture is one of the analyses that were of many that were done to try to describe how Venusian organisms could exist in the clouds. And altitude on the left axis here, 25 to 65 K up, and the density of particles, and this is particle radius size, so small, bigger particles. And so I just back up. So the darker colors, the colors, the lighter colors are well, this is the scale for the density in these different regions. Sorry. So what this graph shows is that particle radii in the lower and middle clouds, that is 45 to 55 kilometers up, can be quite large, more than a millimeter. Particles in the lower haze layer are predominantly smaller. And these points are relevant, as we'll see in the middle. The particles, in other words, in the atmosphere, kind of sort themselves by size. And that, of course, reflects sedimentation velocities, among other things. And you see altitude again on the left. In this case, the scale, the color scale is time scale. So we have time scale here from hour to 10 to the 3,000 years. The larger particles, the larger particles obviously sediment faster. Smaller particles can stay suspended for a long time. On this case, we have coagulation particle size, and the blue curve shows where the time scale sedimentation and the coagulation time scales meet. Oh, sorry, I need to reduce the sensitivity of my keyboard. So the lower and middle cloud layers, coagulation on a time scale of hours to months, so they can live for some time. But smaller particles can be stable for some time. So here's the proposed life cycle using those data. One and two, these are spores, desiccated spores in the lower layer. They get moved up into this sort of habitable zone, habitable layer. In three, the spores become surrounded by liquid. And there's a discussion of this. There are a lot of biologists involved in this, this proposed life cycle that explain how this is quite reasonable, that these microbes should enclose themselves in a water liquid droplet, which would have high sulfuric acid, but they become metabolically active in this. These dash blobs in 4 are metabolically active. It's interesting, they don't comment on it, I don't think, but they show a number in the droplet, which would, of course, lead to one to think about possibly genetic recombination or sex in these little larger droplets. Then the larger droplets, those start to gravitationally settle out and then start to with evaporation, and you get triggering into the next stage in the life cycle, back to the spores, which would return to the lower layer, and they're so small that they don't descend farther and can be retained in this lower dense atmosphere and act as a reservoir, much as our Earth acts as a reservoir for the microbes in our atmosphere. So wind up now. That is a quick survey, but how do we meet our Venusian neighbors? There have been proposals presented to NASA for years, which have been rated scientifically very high, but haven't been funded. Maybe some will be funded, but one nice idea is, and plausible idea, is a balloon which would float above and could be, of course, directed by by an orbiting or stationary station above Venus with a probes and in hanging from the basket down in the cloud layer to collect all the relevant data that one would like to know. Maybe even capture some organisms there have been, or capture some of these droplets, bring captives back to Earth so that we might either meet them ourselves there or bring them back as hostages and hopefully manage to keep them alive. We should be able to ask the first questions we'd like to know, I would think, would be not only the DNA basis, but what kind of energy metabolism do they have? Does that proton gradient that has been fairly recently identified as being the most common, along with DNA, the two common features of all life on Earth? Are they different or are they the same as ours? Lots of questions, but I hope I've left you with a thought that we may actually have some Venusian neighbors, and this really might be better known as the year of Venus and the year of the pandemic. So, any questions? And I can't figure out how to get myself. Good.
I've stopped it for you, Dorothy.
Thank you.
Okay, questions for Dorothy?
I think I just found the what I needed to pick.
Dorothy, I have a question. It's John.
Yeah, hi, John.
Is there any thought as to how complex and large organisms could get in a cloud environment in general?
That's well, yeah, that's an interesting question. Certainly, I mean, a millimeter-sized animal can be very complex on Earth, multicellular. I don't. It's not something that I don't know. It's so how large could they get, as you're thinking?
Yeah, I guess what I'm leading to is, I mean, it's kind of a goofy idea, I think, but you know, we evolved on this planet as creatures that move around on the surface.
Mm-hmm.
But you can imagine flying creatures that never need to get to the surface if they can find everything they need to eat and so on in the cloud.
Right.
So an interesting thought would be, is it possible that on some planets, creatures evolve and live, but not on the surface in clouds where the habitable conditions are just okay for them to evolve?
Yeah, I think it's unlikely that they would actually evolve there, because to get the chemistry going, you need to have surfaces. And in fact, the big difference between our understanding of how life could have started on Earth and before you probably, and we, Miles and I, learned the first in introductory science courses, life evolved in oceans or tide pools in a big, sort of a big cauldron. But that's not the way molecules get together, as you know. It's on surfaces. A molecule, a charged molecule, gets stuck to a surface of some sort, and it captures others that come by. And I don't see how that could happen in an atmosphere to start with. And so I think you'd have to start on a solid surface on the planet, but you wouldn't have to wait as long as Venus did, say, if this scenario is correct. I mean, it seems almost certain that given the similarity of the two planets, Earth and Venus, and now the reconstruction of the conditions on Earth and on Venus that were very similar for quite some time, and the chemistry was similar, we're close together in the solar system. So even if there was a gradation in the elements and the molecules that went into the planets in that condensation out of the cloud, that the two planets should be very similar. So it seems very, very likely that life got started on Venus much in the same way that it did on Earth. Now, of course, if it didn't make it, we'll never know. But what I think is really exciting is it looks as though maybe they did make it. And if they did make it, then they can give us some signs of what early life on Venus was like, and separate evolutionary event, a second evolution of life example. So yeah, that's a thought-provoking question though, John. And actually that made me think of, I said a second example. I didn't mention rushing through everything that's known about Earth, but actually there is some evidence, it's disputed, of course, as it should be, that life may have evolved a second time on Earth and didn't make it early on. It's from some strange fossil evidence, very, very well preserved, strange fossils that have been found in widely, well, in different continents, Australia and South Africa, and I think maybe someplace else. So the problem is that there's no way of getting genetic material or biological material from these. So until, or if some ways divide or some predecessors or some connection is found, but they can't be derived from our lifeline as far as anyone's been able to figure out. They're really different. So maybe life did evolve twice on Earth, but only once made it. And it's not unlikely, but it's very unlikely that two would survive for any length of time. Anyway, I'm going on.
So Dorothy, you showed that profile of the particle size of the atmosphere.
Yeah.
Was the particle size in that sort of temperate zone similar to bacterium, and you had spores? Was it similar to something like a Clostridium spore or something? Or
yeah, well, they're some of them are bigger. They're similar to this. Okay, of course, modeling based on the physical characteristics of the atmosphere and the physics of condensation and of descent through a thick atmosphere. So it's all modeling, of course, but they correspond to a range of sizes that are similar to from small bacteria, but to quite large single eukaryotic cells, millimeters or more.
okay.
It's physically possible, whether they actually got there, but in terms of the physics of the atmosphere, it would be possible for organisms, cells of that size, to be there in those droplets.
Dorothy, could some of this, at least some of the physical properties of what you're talking about, be modeled here on Earth to answer some of the questions about Venus? Well, like the circulation of the particles in the atmosphere, could we do experiments here on Earth to simulate that?
Okay, actually, no, that's, I tried to keep this short and I left out a section on Venus. Something that that has been worked out is the circular, I think this is answering your question, the circulation of the atmosphere on Venus. There, what are those? Reg, help me out. Those cells, air that rises up.
Oh,
Hadley cells.
Hadley cells.
Hadley cells. Got it. Yeah, just came to me. Thanks. Hadley cells that the air rises along the equator, spreads towards the poles, and there descends, and there's a continual flux. And there's actually, I wish I had included, it's quite a nice diagram reconstructed from what's been worked out for Venus's atmosphere. So that diagram, the hypothetical Venusian life cycle was actually based on what was known about how clouds and atmosphere circulates, and it would keep the organisms or these particles along the equator around the middle part of the planet, which is where these UV absorbing dark clouds are observed on Venus. So all these data do fit together. I mean, it's a wonderful hypothesis with stronger evidence from the work that's been come out this year than we've had before. But fits.
Well, very interesting. Thank you so much. That gives us lots to think about.
Okay, what, well, at the end of what? Sorry, I'm having a discussion with Miles. He's whispering something in my.
Yeah. So maybe there, as some people know, there was an eclipse today, and I think some people have some photographs. So if you could get those ready, and I think Lauri wanted to. Hold on a second. I think Lauri wanted to say something about an event that's on the weekend, and then we'll invite Dorothy and Miles back. So Lauri, do you have something to tell us about Saturday?
Yeah, sorry. I thought you were going to do the eclipse. So I just wanted to invite people this coming Saturday to the I guess we could call it the FDAO Solstice Conjunction Star Party, as everything kind of seems to be kind of coming together. It's on the 19th, so Saturday night, starting at about 7 o'clock or so. And we have James DeFrancesco is actually going to be speaking to us, and in the same kind of vein as what Dorothy has been talking about, he's going to be talking about the evidence that there could be life on other parts of our solar system. And he's going to not just talk about Venus and some of the things that Dorothy has kind of talked a little bit about, although she's gone into much more depth than what James will. But we'll also talk about some of the other parts and whether or not we could look for life in many forms, possibly in other parts of the solar system. So he's going to be doing that for us. And we're also going to be talking a little bit, of course, about the solstice, and if we have good weather, David Lee is going to try to do some live streaming from up on the deck or up on the parking lot for what is happening out there. I'm not sure. I don't think, David, it doesn't look very good, does it? But we're also planning on opening up the Plaskett for live streaming as well, if it works. But again, if it doesn't, if the weather doesn't hold, then we'll be able to do some other look at some of the pictures from the Plaskett. We're hoping to make this a family-friendly event, and considering some more, for younger people or for some families that might visit us, having a few interactives at the beginning. in order to have some of the kids involved as well. So please come along. The link is on our centeroftheuniverse.org page. If you just go to the front page of the FDAO website and just click down into December 19th, it'll take you directly to the link that will get you onto Zoom. So we hope you all will join us. We're hoping to another year we would be offering you, eggnog or something like that up at the center, but we're going to have to maybe keep that until next year. So, but it'll be virtual this year. So come along. Thanks a lot, everybody.
Thanks, Lauri.
Could I just, since
Sure.
Lauri, I just wanted to say, Lauri mentioned James DeFrancesco will be talking. I didn't mention it, but he just a month or so ago, he gave a very nice talk, which I think this one will be
Yes.
an elaboration of it to
The students at UVic.
up at UVic. It was
Yeah.
really good. It was nice. And he ended with a mentioning of phosphine and a bit of skepticism.
Yeah. I think it's going to be quite similar. So if you were then we're having him kind of come.
It's good. He gave a very good talk.
It was
fun.
good. Yeah.
Am I permitted to, this is Miles. Am I permitted to say something non-astronomical?
Sure, go ahead. Why not?
Thursday the 17th is Beethoven's 250th birthday. That's 250th. So don't forget to celebrate.
Yeah. Monumental day.
We'll all
Clear,
sing.
Reg.
Listen to a string quartet.
There we are. Yeah, so there was an eclipse today, and I think Randy had found some photographs, and I don't know if anybody else had. But do you have those ready, Randy?
I do. That's not the right screen. Hold on.
That's an interesting eclipse.
Yes.
Let's go back to here and here and here. So first of all, I woke up this morning and just in the Facebook was lovely watching things coming in real time. And I particularly like this Goes East series. So this is Pacific time at 5:30 this morning. And you can see the day moving across, and then you start now seeing the shadow. There we are at 6:20, 6:30, 6:40, 6:50, 7 o'clock this morning, 7:10, 7:20. Now people are starting to show pictures of the notch out of the sun. And wouldn't it have been nice if it were just a bit more north? It was perfectly clear up around Buenos Aires, but down in Patagonia, we had a lot of cloud. There are probably a lot of disappointed people. For some reason, there's no picture at 7:50. I don't know what happened, but I checked a couple of times. It's not there. Going across, and I was watching just as I was getting ready for breakfast this morning on the live stream on YouTube, and it was spectacular. It was beautiful. And there it's going across. I'm really interested in these, how, depending on the clouds, you see these different shadows. You see that great swath across on the clouds from the oblique shadow. And there it goes off. We're at 9:30. I think I went till 10 o'clock. And then just this one picture, which I'm using as my my background. There'll be a lot more of these, and I'm sure I will cover this in Enkin's Daily Moon. But here we are from a picture. And it turns out Argentina was much better than Chile for this one just because of the clouds, but there's quite a spectacular, oh, what's the word? From
Prominence.
Prominence.
prominence. Thank you. That's amazing there, isn't that? Okay, that's what I wanted to show.
Thanks, Randy.
Beautiful.
Did anybody else have anything from the eclipse, or?
Yeah, I can follow up on that one.
And just while you're getting ready, if you haven't seen the note, Jim mentioned that the Lafayette String Quartet is performing Beethoven on Wednesday evening. And I guess that's available. Is that available from the UVic website, Jim? You just nod or tell us.
Yeah.
Yeah, thank you.
It is.
Yeah, so have a look at UVic and see if you're interested.
So I just thought I would show the Facebook page for Mr. Eclipse, Fred Espenick. So this is the first time in 30 years that he has missed an eclipse, solar eclipse.
Yeah.
Yeah, that's pretty good dedication. So he and his wife decided to have some pisco sours, as you can see by this first picture here. And I'll just, he was with his friends. There were a few people that did go to Chile and Argentina. Obviously, Argentina was the much better choice because the clouds pile up on the Pacific side of the Andes. So you're in a bit of a rain shadow on the Argentinian side, but of course it can still get very cloudy up there, as we saw. And I think he was happy to show off the same animation that Randy just showed. He's pitching as the two eclipses that are going to cover North America. For those of you who aren't into eclipses, these are the dates to look forward to. There's an annular, which will go through Oregon, certainly within driving distance of us, in 2023 on October 14th. And the big one, the total solar eclipse, will track all the way from Mazatlan in Mexico all the way through to Newfoundland, right across the North American continent. And if you want to go to exactly the same spot to see both of those, you can do that if you just go to Texas. And there is one more clever thing down here somewhere. Maybe I'll carry on. So I did capture a couple of photographs off the screen this morning, so I'll just flip through those for you just so you can see them. This is just before, this is a partial eclipse. Of course, you can see the thermometer on the bottom as to what stage it's at. And this is just before totality. And as you probably are detecting, these are shot through clouds because the whole area there was fairly cloudy, but time and date did have a pretty good feed, and it was video. So these are just video captures, but you can see the diamond ring at the start of the eclipse, and just a few seconds later, and you can see some of the hint of Bailey's beads there at the 10, 11 o'clock position. And they're fiddling with their exposure with the video, of course, because it's transitioning. And there's some Bailey's beads on the left side there. And the diamond ring as the totality phase finishes. And then the end of totality. So I just thought I'd share those.
Thank you. Reg, did you have anything for us this evening?
I'll just share the screen and see if I can find what I was going to show.
Can I just ask if there was a clear patch that somebody did do the entire thing that was clear and not in the clouds?
Well, we will find out in the next few days. Keep watching the internet.
Oh, okay.
They'll post them, I'm sure, if there's
Yeah.
any good ones available. And by all means, check out Astronomy Photo of the Day and spaceweather.com. That's where those will be the two sites that'll have the best shots.
Okay.
Okay, well, what I've got here is if people are having trouble finding the link for the FDAO Winter Solstice Star Party, it is here. And I've got the time right this time, Lauri, and I didn't mess around with any links. This is just a link taken from your website to get to the information where you can log in and find some more information about the Winter Solstice Star Party. I hope it's a great success. And then just a little bit of information about the Great Conjunction and the not quite so great conjunction on Sunday, which I guess we'll keep an eye on the weather, and I might send out something on Sky News if it looks favorable for Sunday for people to have a look. There's really not very much difference between the two. The closest approach between the two planets occurs early in the morning of the 21st. So Sunday evening and Monday evening are roughly the same situation. It's a little bit closer on Monday evening than Sunday. So I hope the weather works on one of those days. I just wanted to briefly mention that for those who, I think pretty much everybody gets these messages from the RASC Weekly Insiders. They've got one thing on Tuesday, Insider Guide to the Galaxy, or they're going to talk about observing with binoculars, and you can register here on the site. And if you do not get this message, please email the president, and I'll give you the link of how to subscribe to these weekly messages. They're very handy. And then on Friday the 18th, there's a program about the Star of Bethlehem. So it might be to do with the Great Conjunction. I'm not sure. Check that out. And the Astro image of the week is also an annular eclipse that a person took in 2012. And he won a contest. And then they are talking about actually imaging the Great Conjunction using RASC robotic telescope. And while they mentioned that, they're saying that the data is available for purchase if people want to get the raw data from the robotic telescope, and they think it'll make a lovely Christmas present. So there you go.
I gave myself an early Christmas present and paid the $100 for the 2 years worth of data. I think it's quite a bargain at $50 a year.
Okay,
if you're into that sort of thing.
Excellent. Then the observing targets this week, the Geminids, unfortunately, were obscured by cloud here. And you talked about the solar eclipse and the new moon, I guess. There's not too much else there. And I think I'll leave it there, except that there's a couple of big things that we haven't even mentioned at all. And one is the successful landing on the moon of the Chang'e 5 Chinese mission, where they actually picked up the material from the lunar surface. An ascent rocket went up and rendezvoused with the orbiter, which was a really major achievement. And it's back on its way back home now. And I've been having trouble to find out precisely when it's coming. They seem to be artfully vague in China, saying it's coming in sometime on the 16th. So maybe other people have a better idea of that. And there is also SpaceX had a prototype Starship rocket that they've got big plans for, possibly going to Mars with that, or at least to the moon. And they did a test of the upper stage of that, and it went up eight kilometers in the sky, and then it came down, and just as it had a beautiful maneuver to gently land on the Earth, it blew up. So you might want to check into the Starship rocket explosion if you're into that sort of thing. And I'll just stop there. Back to you, Chris.
Okay, thanks, Reg. So does anybody have any final things for us this evening, or is that it for tonight? Very interesting evening of things. So I guess hearing none, I guess we'll, or John, were you saying something? I think you're muted.
I just wanted to thank Dorothy for the talk. I thought it was very good.
Yeah, it was as I say, a very interesting evening, and it was, and thanks to Randy for taking me up on the showing the sextant as well, because that was nice to see exactly how that works. I was unfamiliar with that, and so are we going to find life in the Venusian atmosphere? Who knows? Huh? But it sounds like it could be there.
Yeah, stay tuned.
Stay tuned. Well, thank you so much
Look
for
at
putting that all
Venus.
together.
Thank you. Thanks a lot.
Okay, well, thanks everyone, and have a good week, and we'll see you again next week.
Bye-bye. Good night.
Okay.